Okay, let's do some more C++ as we're learning CS101. In this one, we're going to look at how to do looping primarily, and then a little bit about some arrays, maybe using some STL classes around list management, that kind of stuff. So let's get into it. Go into my 2021 folder in CS101, and I am going to create an app today that the program is going to guess a random number, or pick a random number between 1 and 100, and we have to guess that in a certain number of turns. So I'm going to call this guesser. And I'm going to use the touch command to touch a file called guesser.cpp. That just creates an empty file. That's the way that you do it in Unix land. And also ls-la, which is the Unix equivalent of like a dir in Windows land. So let's bring up VS Code on this one. All right, guesser.cpp is empty. Not good. So let's go and add some stuff in there. I don't need the files on the side. What do I need? So I'm going to need some input output. So let's bring in IO stream. I'm going to need a main. Always need a main. And in this case, I'm just going to turn 0 out of it. And let's see, I'm going to use the namespace standard so I don't have to write std all the time, like std sin and std sout and all that stuff. Okay, so first thing we need to do is guess a random number. So the way that I do that is I do like int, and I say value, let's call it that, and then give it a rand, and do our modulus trick, and we'll pick 100, and then I'll just add 1 to that. So it's going to be between 1 and 100. And we also need to kind of initialize that, so we always get a different random number every time. So let's just do srand for seed the random number, and then I'm going to do times 0, and that's just going to give us always a random number that is unique. And just to check to make sure that that works, let's do a cout with that. So I can say picked chosen value is, and then value, and then endl. All right, let's g++ that. Guesser.cpp, and then out to guesser. All right, let's try that out. Oh, 39, let's see, 53, looking pretty good. And just to make it easier on myself, I'm gonna do that thing where I do and then /guesser, so that if the compile works, then it automatically runs my code. There you go. Okay, cool. Good start for that. So let's say that I want to make sure that people can guess this number in 10 tries. How about that? So we're going to create a loop. We're going to go around 10 times and learn some stuff about how to do that loop. So how do we do that? Well, if you're counting from a thing to another thing, really the most conventional way to do that, there's 3 different ways to do looping in C++. And the most conventional way to do a loop, where you have a discrete start and end, is a for loop. So we start off with a for, and we'll add the curly braces. And so what do you need in a for? Well, you need to define what your counter is. So you'd say like int can be is an integer counter. And you get to call it whatever you want, but sort of by convention, people call it I equals 0 in this case. We'll start it off at 0, the first round. Where does that come from? It actually comes from Fortran. If you really want to know your computer history, back in the day, Fortran started off with defining by default some variables, which is really unique. You don't really see that nowadays. No programming language I know, modern programming language, predefines variables for you. But I think they predefined I, J, K, and L as all integers. And my guess was that was to save punch cards. So yeah, that's a little history tidbit for you there. I don't know if that's the case to save punch cards, but yeah, it's a reasonable bet. Okay, So the first part of a for loop specification is the initializer. And then there's the test. So this is how long are we going to stay in that loop? And we're going to stay in that loop as long as I is less than 10. So it's going to loop forever. Well, it's going to loop, 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 loop. And then eventually it'll stop when this test is no longer valid. So, and it starts off, the reason that the loop starts is because I is 0 and I is less than 10. And then what do we want to do on every loop? Well, we want to go and add 1 to that I, and the one way to do that is I plus equals 1, like that. Or I equals I plus 1, if you want to go really verbose. But the way that most people do it is they do I plus plus, which means it's just shorthand for add 1 to I, which, by the way, kind of gives you the joke right away about, C++ is in relation to C. Obviously, C++ is equals C plus 1, or whatever, C plus equals 1, which would equal D, I guess. I think there actually is a language called D, so that's why it's not called D, it's called C++. Okay. So we want to go and ask the user to give us a value. So I'm going to create a new function for that. Call it get value. And I'm not going to put in the return type or anything like that. I'm just going to go and kind of walk through the code. So first thing we want to do is go and ask the user for the guess. So guess number. Okay. All right. Well, we need the number. We need the index of the guess. And then I'm going to put in a space like that. So we need the guess first. So that's going to has to come in as a parameter or an argument to our function. And now is the time we should start talking about some typing. So in this case, I'm just going to pass in this value, I. So that is an integer, so it should just match with that. And then we're probably going to return an int out of this because that's what we want. We want the user, person, game player to type in a value and give it back to us. So there you go. We're going to return an int. We're not doing that currently, but we will. So we're going to say get value down here, and we're going to say my guess is get value, and then give it I. That's going to start from 0, right? So that's not going to look very good. People don't like to get guess number 0. People think is 1. 1. Everything starts at 1 if you're a human. So, let's do that. Okay, so we'll add that. And now we want to go and get some input. So we'll say cin to my guess value. And then we'll go and set that. We'll initialize that because we're nice about that, and we'll return it. All right. Cool. So now we got a nice little helper function there. That's cool. We could put all that code in here, but it's nice. I myself tend to keep my functions really short. That's just years of looking at really long functions have given me a sense that it's a lot easier to trace things when the function is shorter. So I make lots of small functions and smush them together as opposed to making mega, mega, mega functions. Okay, so let's go check to see what this value is. So if my guess is less than the value, then we're going to do something. If it's greater than the value, we're going to do something else. And then if it equals the value, which we could put the conditional in here, but I think, just by it's either going to be less than, equal to, or greater than, so we'll just put else in there. We're going to do something else. Okay, so let's start filling in the blanks here. So if it's less than the value, I'm just going to say cout. Hey, it's less than that. You still need your semicolons, don't you, C++? You're always about those semicolons. All right, and then we'll say more than that. And then what do we do in this case? Well, in this case, we want to break. I'm going to get out of this. We're done. We nailed it. You win, right? So first off, we'll say you win. Congratulations. You nailed it. You win. And but we need to get out. And so the way that we do that in C++ is we use the break. So you say break. And what that does is it says whatever the current loop that I'm in, whatever kind of loop that is, as I said, there's only 3, but we're using our for loop right now. I'm going to break out and I'm just going to go to the end. And at that point I could say, see out, I guess, you got it in something guesses, like I guesses. Oh, and then we got to put that endl on there, right? But now we don't have access to I. That's kind of an interesting thing. So here's something interesting and cool. You can actually just kind of pull this out if you want to. And that's fine, actually. It works just fine. You can have empty segments in a for. So yeah, that's okay. Oops, endl like that. Is that what you're worried about, C++? Okay, that looks pretty good. All right. Well, let's run our G++ again and see what it comes up with. Chosen value is 4. So I'm going to say, so the way I would beat this, by the way, is I would use what's called a binary search. So if you got 100 values, right? Go split the difference. I'm gonna say 50, right? I'm gonna guess that I didn't know what that was. I didn't know 4. I'm just gonna guess. So by the way, let's clean up a few bugs here. Let's go and add some endls in there. I keep thinking this is JavaScript and I automatically get my endls for free, but I don't. Okay, so my next guess would be then if it's less, I'm going to split the difference again and go with 25. More than that. Sorry. I guess, is this inverted? It's less than, my guess is less than the value. Yeah, I think that's right. So, because it's giving me the wrong notation. Well, let's do that fix. Let's add our fixes and then run it again. So let's see, 31. Again, let's try 50. Less than that. That makes, hey, okay. Now we're getting the right direction. Okay, so now we split the difference again. The difference between 0 and 50 is 25, so let's go with 25. More than that. So let's see, between 25 and 50 is 25 again, maybe half of that. So we'll go with 37. So we want to go up. So now it's 8 between 25 and 37. So we'll use 4. So now we'll go to 33. Would be the case. Less than that again, so 33 to 37 is 2. So I'll bring that down by 2, 31. Hey, I got it in 4 guesses. Nice, okay. And I don't know, for you math geeks out there, I believe that's log of 100. I don't know, what is the log of 100? Isn't that something that I can put in Google? Like just like that, Google. And say like log of 100 is 2. Oh, well, I didn't get there. But anyway, so I took a few more passes at it. All right, so what are some things that are issues with this? So if we run this again, I can put in negative 500, right? And that's not great. So we need to do a little bit of checking on our inputs here. So we want to go and actually wait for the user to enter a value that we like. So what are we going to do with that? Well, we're going to loop around this until we get something we like. So let's pull out this guess value. And what we can do is we can say while, and that's there's 3 types. There's for, there's while, and then there's do while. And we'll put in a little space there, and I'll say while guess value is less than 1, or guess value is greater than 100, then we do this. Let me fix all that up. So here's the idea. We're going to loop in here until we get a guess value that we like. And that guess value has to match these 2 conditions. It has to be either greater than or equal to 1 and also less than 100. So in this case, we start out with 0, which is obviously less than 1. So we pass that, and then we don't even look at this. We don't even look at that second conditional. If that first one passes and you're in an or statement like that, you just go with it. So let's give this a try. And try our minus 500 again. See what happens. No, we don't like you. Okay, so let's try 0. Nope, don't like that either. Let's try 101. Nope, don't like that. Let's try 100. Less than that. Okay, so yeah, looks like we're getting some decent tracking in there. And we'll just be nice, add ourselves some returns, make it look good. I'm just going to show you the other flavor of this. Just, if that's interesting to you, I'll comment this out. And then I'll show you the do while variant of this. You don't see this that often, but there's reasons for it. I mean, it's a nice feature. So you start off with a do, and then you say while at the end. And here's the salient difference. So in a do while, you always go through the loop once. So your CPU starts off with setting the guess value to 0, and then it comes down here and it looks at this do it. It says, great, I'm going to do that, and it does this, and it does that, and then it looks to see if it can exit the loop. Whereas in a while, like this, it starts up here, it sets the value to 0, and then it checks to make sure before it even goes into that loop whether it needs to go into that loop. And it's just, potato, right? Sometimes your semantics of your problem are that hey, I want to check first, right? As an example, hey, iterate through this array, right? Cool. What if the array is empty? I don't need to go into that, right? So I check first. But in this case, I actually think do while is maybe a better semantic for this because, honestly, we know we always want to ask at least once what the guess is. So, not something you see all the time, but definitely do it, something that is worth knowing about. Specifically also, I would say, because JavaScript, C#, Java, they all have these 3 loop variants. They all have for, they all have while, and they all have do while. So this is pretty cool. By learning C++ on this, you're actually learning about a bunch of different languages, all of which kind of derive from in the language tree from C. You started with C, and then you had C++, and kind of Java came off that, and then C# came off that, and JavaScript kind of comes out of that a little bit. There's definitely some overlap there, so it's good. You're learning good stuff when you're learning this. Okay, so let's talk about arrays a little bit. And actually, let's talk about continue first. That's one more thing you might want to think about in terms of how to control the functionality of this loop here. So I'm going to move this I++ down to here. And actually, there's no semantic difference between these two, right? This is exactly where I++ is running anyway. So that's fine. Conceptually speaking, I didn't make any change there at all. Let me go and run this just to show you that that's truth. So 50, less than that, 25, whatever, yada, yada. So that works. And you can see the guess number is increasing so that I++ gets run. Well, let's say that we want to make this fun. We want to have a little thing in here where we say you can get a free guess, right? Let's see, if we have a random number between 0 and 5 and it's less than 2, then we say, hey, you get a free guess. And then we don't want to charge them the freight. We don't want to, add that number. So we say, free pass. Now, what we could do is we could just do something like this, right? We could just else and then I++. That's fine. That's totally cool. That would basically be the semantics for that. But there is a nicer way to do this, and that's to use you got two different ways to control flow inside of a for loop. One is break, and the other is this continue. Now they say that naming things is the hardest problem in computer science, and I don't disagree. I really don't. It's important, and continue is a terrible name for this, because continue to me, when I look at this, it says to me continue on with this loop, right? And in other languages like JavaScript, we actually renamed this to next. Which makes so much more sense, because that's actually what it means. Continue in this case means continue on to the next in the loop. Go back to the beginning of the loop. So what happens is this. So your CPU starts off at 0, goes into this for loop. I is less than 10. Great, we're in. We get the value. We go through this whole rigmarole. Let's say you don't win, or or the CPU is going all the way down here. It goes into here. It looks at this rand, and this rand says, great, free pass. So the CPU jumps in here, says like, oh, cool, let me go and do my free pass thing. And then it hits this continue, and then immediately it goes, whoa, all the way back. Oh, hold on. It goes all the way back up to the beginning of that for loop again and starts again. Right? So that's what continue does. That's kind of cool. All right. So now you know about for loops, you know about break, you know about continue, you know about while loops and do while. Let's talk a little bit about arrays. So let's just say that I want to tell the player all their guesses. They didn't know. They played this game for all of a hot 5 seconds, but it slipped their mind what they said. So we just want to store those values. So we'll create a new array of integers called guesses, I guess. And it's going to be, let's see, 10. It's going to be a size of 10. You get 10 items in your array of guesses. And that's one of the things about arrays, is in C++, particularly with arrays defined right here, and I'll get in later videos on what right here means. It actually means what's called on the stack. You have to define how big they are, right? And that's kind of a hassle. Like in other languages, you don't have to do this, but you're starting to see that like C++ makes you think ahead about how you're going to use memory, how much memory you're going to have, all that kind of stuff. So in this case, we have 10 different rounds and we have 10 different guesses. So in fact, actually, if I was a normal me, I would probably just add a few on there just to make sure that we don't overrun anything. So I'm going to, oh, whoa, okay, that's interesting. Oh, that's the text. All right, so let's see. I want to go and add in to guesses the guess. I'm going to say guesses. And then again, I use the brackets, and the brackets are a subscript, essentially, in math terms, I guess. You could say my guess, or I equals my guess, right? So I go through here, I initialize my guesses to an array of zeros, so it's 15 zeros. And then I go in and go through this for loop, I get a guess, I set that index of that at that index to that guess. And now I'm going to go and output it. So I'm going to create another for loop. And again, I can use I. I can reuse that, no problem. I'm going to say I is less than 10, I plus plus, right? And you know what? I should probably put that up there. And I'm going to put guess number I plus 1 was, and then I want to put in what my guess was. Guess sub I. There you go. And that'll tell me what my guesses were. I guess. Wah, 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 wah. Sorry. Why does it like this? So let's see. Problem? Problems? Who's got the problem? Oh, it's guesses. Okay. Guesses. Blah, blah, blah. Guess. Big guesses. Okay. See how much nicer it is to work in Visual Studio? It tells you things. Okay, so we start off 63, and then we go 50, and then you know what? I'm just going to go with it. So 63. Okay, that's an interesting one. So let's take a look. So we said chosen value is 63. I did one guess at 50, which is recorded there. I did another guess at 63. I nailed it in 2. I won. Woo! And I got it in 1 guesses. That's wrong. So let's do that. I plus 1 there. And then I went through and I said the first guess was 50, second guess was 63, and this one was 0. Okay, so how are we going to fix this? Let's see. So I could go here and I could say if guesses at that index is 0, then we'll use that handy dandy break, right? Let's try that. Okay, so let's run this again. 90. Let's hit it in 2 again. Oh, I got a free pass. That was cool. So I got it in 1 guess, and that first guess was 90. Ooh, interesting. So not only, yeah. So that's interesting too. I put it before or after I put that C out there. So I get the guess was 0, and then I look at it. Oh, it's 0. I probably don't want to print it, right? So I can put it in there. Let's see. Is that going to help? Let's try one more time. So 50, 25, 28, 28, Jack. There you go. Cool. All right, that's looking pretty good. I guess one more thing that I could do, because really, right, the semantics of this are that it checks this every time. So if I was to go over here, I could just add this. I could say, if I is less than 10, and the guess that's at I is not equal to 0. So, by the way, boy, that's if you use exclamation point and then equals, that gives you not equals. Now, my goofy little font thing with ligatures shows it like this. It's really just an exclamation point and equals. So let's try that. Let's see if that works. 62, so 50, 62. Yeah, that works. Cool. So understanding the semantics of what is going on with this for loop and looking at it like basically a kind of a toy, right, or a puzzle or a Lego construction set, whatever you want, however you want to look at it, and just look at these parts and pieces. You know, you have an initializer that, hey, I don't have to use it if I don't want to. I can just say, you know what, just start that loop up. You've got a test portion in there, which could be like I equals 10, or it could be whatever you want to do, whatever applies to your loop. Like in this case, if I is less than 10 and the guess is not 0, that's fine too. And then the incrementer section, which you can have or not have. I mean, honestly, in C++, a valid loop is that. You could do that. That's no problem. But so you can go and tweak these pieces however you want. I remember when I was working at a neuroscience job once, a guy actually had a for loop where it could run in both directions. You could run it forward or you could run it backwards, and it used some tricky ternary logic to figure out like which way it was running. It was an interesting approach. I wouldn't call it particularly maintainable, but you know, that's fine. Now there is one issue in here, right? You get the free pass, but we kind of overwrite the value. So let's say you get a free pass for the second guess, right? We're going to overwrite the second guess in there. And the way that I would fix that is instead of using an integer array like this, what I would probably use is something like this list, right? So this is the list, comes from the standard library. So let's go and have a look at how we can do this. So really what I want to do is get to this pushback thing. So I'm going to use this example. So I'm going to include list like that up at the top. And let's see, how do I define a list? Well, I'd say, okay, so a standard list. Well, I don't need the standard part, so I'm just going to use my list like that. So I'm just going to replace this with that. So I get a list of guesses. Now, do I have to do it anymore? Nope, looks pretty good. So get rid of that. So now we have this list. And the cool thing about a list, so why are we doing this? Well, a list, it'll expand infinitely for you. You don't need to worry about saying I have 15 or I have 100, whatever. It's going to go, and every time you add in a new item, it's going to get bigger. So how do you do that? Well, in order to do that, well, oh, wow, look, it's actually hinting. So we want to push to the back of the list that integer value. So that's that my guess right there, right? Okay, so pretty cool. So every time we get a new guess, regardless if we've got a free pass, we're going to go and print it. We're going to go and add it to that list. So how do we go then and actually iterate through it? Well, okay, let's take a look and see. Probably around like begin. That's going to show you how to iterate through the stuff. Yeah, okay, there you go. Let's take a look at this. So, all right, we've got ints like that. We got a standard list of ints just like we do with my guesses. And now we're going to go just kind of copy and paste this iterator here, and we'll just walk through it. So I'm going to get rid of this. Actually, you know what? That's fine. Keep it around for a second. It's obviously invalid since guesses is not like that anymore. So let's get rid of the standard stuff. Okay. So we've got a list iterator, and that list of type int, and we have a guesses, and we're going to start at the beginning of guesses, and then we're going to iterate until we are not at the end, which makes a lot of sense. Okay, pretty cool. And then we're going to add on to integer. We're going to move the integer ahead. Now, that's actually kind of an interesting thing. In C++, you can do, or actually in all these languages, you can do a pre-decrement or pre-increment or post-increment. So pre-increment means plus plus C, means increment before you evaluate the value, and then post-increment means C++. Like it would be like that. Like, increment the value and then check it. And if you're really, 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 really into performance, pre-decrementing is actually slightly faster than post-incrementing, or pre-incrementing is slightly faster than post-incrementing because you're actually changing the value in place. That's why that's the case. All right, so let's open our curly braces again. You don't have to, but I like it. And then I'm going to take this part and paste it in there. And let's see. So they're using the asterisk IT, which means the value at that iterator. So this is pretty advanced. So, we'll look at this a couple of times, but there you go. And we'll take these guys out of there. So let's take a look at what we're doing here. Guess number X. Oh, that's interesting. So I still need an integer. So that's okay. Yeah. All right. Let's restart I equals to 0. And then we'll also put I++ there. Is that going to work? I think that's going to work. Or didn't like that again. Let's do I equals 0 here. All right, cool. All right, 74, so let's do our thing. 50 more, 75 less, 74. Okay, cool. All right, neat. Okay, so here's what happened. We created our list, which in this case is a dynamic list based on a data structure called a doubly braided or doubly linked list. And then we add on to it every time, just add more guesses, which is really cool, even if we got a free pass. And then down here, we get an iterator, which is just like a thing that kind of tracks where you are in that list. We started off at the beginning, and then we iterate. We move that iterator, and we watch to see if it hits the end. So we loop as long as it's not equal to the end position. And then every time we pre-increment it to move it on to the next position. And then down here, we just output it, and we use that star to get the value of that particular iterator, which would be what it is as it traverses along that list. So there you go. Multiple ways to do looping, some array stuff in there, and then finally a more flexible standard library-based iterator. So enjoy. I hope that helps. And if you have any comments or questions, be sure to put those in that comment section down below. Feel free to, of course, like and share this video with your friends. Subscribe if you're into all things front end and full stack, and maybe a little bit of C and C++ and CS101 as well. But of course, in the meantime, from me to you, be happy, be healthy, and be safe.